Okay, we have everybody. Hi, Chiang, how are you? Hello, hear me?
Yeah.
Hi, Chiang, how are you?
Hi. Hello?
Hear me?
Yeah, fine. Can you hear me?
Yeah, what's your question, actually? I cannot see which chapter you give me this, and I cannot log in. So what's the chapter, which chapter it is? When I click it's like
17.
this.
The 17 project.
17 project, okay, let me look at it. No, this is wrong. Let me see. I think it actually linked to the wrong data, okay? I'll check it, okay? I'll check it. Let me check. I think it actually have the wrong link. Maybe this one. Oh, no. I think it's chapter 17. It should be this one. Okay. I'll send it over. I'll actually so that slice is wrong. I'll give you this one, okay?
Okay.
So let me actually copy it. Maybe you can access it right now. Thank you for reporting it. Actually, this one is a mislink. Okay, sorry for it. Okay, any other question?
No.
No? Okay, we will continue our discussion. Last time we actually lost 1 week for the review of homework. So we'll try to catch up, okay? We'll try to catch up. So before we proceed, let's talk about the schedule. So first thing is the holiday policy, okay? So November, we would have Thanksgiving. So during the Thanksgiving week, what we will have is no coding practice. So Monday to Friday coding practice during the Thanksgiving week is totally off. Lecture still will be there because we are behind, so we don't want to lose our lecture. So Saturday lecture will still be there, but coding practice the whole week will be canceled because a lot of people would have the Thanksgiving break. Okay, any question?
No.
No.
Okay, that's the number one for the Thanksgiving week. Second, for December. December, we will have half months off. So December, we will only work up to 14. So let's see, let me bring, okay. Let me bring the calendar, so. So December, let's see, December we will work until I would say the Sunday of the 14th will be the last day for any class. After that, we are off. We are off. So you can do travel, okay? You can travel. Then we will come back on January. So January right now, my plan is to start on January 10th. Okay, so there's 1 more week you can use for traveling. But I'm not sure. Maybe we will add a class on 3rd because we lost 1 session. So we may use this one. I'll talk to students to see how many people are willing to have class on this day. Okay, is that okay? So right now, if no further announcement. January, we're starting from 10th. Okay? Is that okay? If no further announcement, January, we're starting from 10th because the 3rd, sometimes some students still missing, haven't come back. Some travel to Korea, some travel to different locations. We don't know. Right? So, is that okay? Some travel to Asia. So some students are missing. We cannot have everybody. So that day I may add a day on here, but may not. I'll talk to parents and students to see how many people really are interested to add a class over there. Okay, because we lost one week on there. Okay, so this is about the schedule. Any problem about the schedule so far?
No.
So our plan still be based on what we have right now, still be we still have 5 sessions to finish the APCSA. So look like APCSA will be finished on November maybe 1st or 8th. We will be done over there. Okay, we will be done over there, and then starting from there, we will do APCSB, the B part, and UCircle part. We will start that. Okay, so be aware that the new course will get started soon, and that will be more challenging. Okay, that will be more challenging. So that's the schedule, and we may add a day in the early January next year to catch up, but we don't know. So at this moment, what you are doing right now is we are almost done with the Java 1. Okay, almost done with this. Moving toward to Java 2 and 3. Java 2 and 3, these are the B course. I would say B course is mostly Java 2. 3 is still not that easy. There are still something extra for data structure and algorithm. So data structure and algorithm is a separate course. Okay. Anyway, in high school, we suggest students to have at least one language that can reach the level 3. No matter which language you have, at least one language it should reach level 3. Okay, it can be C++, can be C++, can be Java, can be Python, can be JavaScript, whatever language you have, but you have to reach level 3. Okay, Berkeley's first course is actually level 4, level 3 and 4. Berkeley CSCT1A is sitting right here. Okay, so you need to get prepared, otherwise you cannot catch up their level. And 4 language ready in high school, you need to have Java, C++, Python, and JavaScript. 4 language ready, but at least one of the language need to be on level 3. This is what I want to have for high school students. Okay, and this chart is what I'm teaching. I'm using for the teaching at the Louis University. Okay, I'm teaching the course programming language there. This one is a college senior course. So this whole thing is the core computer science knowledge that you eventually, after you get the CS degree, you should have these different knowledges. But go as far as possible. And high school or CS major students should go to here at least. That's the minimum. So right here is about UCircle Gold. If you have the UCircle Gold, you roughly are at this level. Okay. UCircle Silver don't need that. UCircle Silver probably just up to level 2 and some data structure. Okay, that's what I want to say. Now go back to our material. So today we continue to work on chapter 17 and 18, the 2-dimensional array. That would be the last data structure that we want to cover for the AP Computer Science A. Then chapter 19 to 20 will go to algorithm. So algorithm is no longer language related, it's actually more problem solving. Okay, so it's a different unit for chapters 19 to 21. There are 4 or 5 chapters there. Okay, so today we'll try to get started for this two-dimensional array, and this is the last data structure related chapter. So we'll be on two-dimensional arrays. So basically, we'll teach what is two-dimensional array and what is multi-dimensional array. That's what you need to know. You need to know how to create two-dimensional array and how to do two-dimensional array traversal. This is 2D means two-dimensional. Okay, so two-dimensional means you have two index, I and J, two index. One-dimensional means you have one index and go in here. Okay. Now, okay. Let me actually teach you about some knowledge, okay? So when you have available, when you look at the mass you have available, you have X. Okay, X is available, so you can store some value to there. So this is X, we call it a scalar. Okay. When you have like when you have two-dimensional, you have data that has X, Y. This is seen, we call it a vector. So a vector is two-dimensional data. We call it a vector. I'm sorry, one-dimensional data. It's one-dimensional, two tuple, one-dimensional data. One-dimensional array, we call it vector. So when we have two-dimensional data, okay, you have I and J, and then you have metric. This one we call it metric. Two-dimensional data, we call it metric. Okay. And then if you have three-dimensional data, you have these. So this one you have I, you have another one J, you have another one K, three index. Okay, let me check. How about Kingston? Hear me?
Yeah.
What is the name of the three-dimensional data?
Three-dimensional array. 3D array.
You can call it 3D array, but there is another name. One 0D, zero dimension, we call it scalar. It's a S variable. One dimension, we call it vector. That is actually V1, V0, V1. Okay, that's one dimensional vector. Two dimensional, we call it metric. Three-dimensional or more, three-dimensional, four-dimension or more, we call it tensor. Okay. So when you look at the AI right now, they have a lot of tensor processing unit. It's by Google. Google has this tensor processing unit. They are dealing with all kind of the tensor computation. That means they have very high dimension data being pumped into the processor to do calculation. Is that okay? So this is tensor. So if you do Python have one package called TensorFlow. So TensorFlow is handling a package handling the tensor for machine learning. It's okay?
Yeah.
So Kirsten, what am I trying to say right here? Why am I talking about tensor right here?
Because there's a lot of ways to store data.
Yeah, it's the way to store data. So what we want to tell you is that multi-dimensional data is the origin of the machine learning. Your machine learning is dealing with multi-dimensional data, and multi-dimensional data is called tensor. Here we teach you two-dimensional data, but that's not the top. That's not a limit. You can continue to explore three-dimensional, four-dimensional, five-dimensional, 100 million bi-dimensional data, and that would be the machine learning. Okay, that would be the tensor, would be used for big language model for machine learning. So this is the starting point of the machine learning. You got to know this. If you don't know about multi-dimensional data, you are not able to handle it. Okay, so that's the first thing that you need to know. We use the multi-dimensional data to model a lot of learning models and then do computation on it. Okay, so this multi-dimensional data is the key, a very important idea in advanced computer science. Okay, so you need to use a two-dimensional array, and then we'll talk about the different algorithms in two-dimensional array. That's the key for this chapter. So we'll teach you how to declare, initialize, and instantiate and initialize a two-dimensional array. Okay, so first thing is like the motivation. Why we want to use a two-dimensional array? Because you may have metric operation. You may have this the so-called chess ball game. All of these are two-dimensional data, and you actually deal with it every day. Okay, so two-dimensional array is very popular in a lot of computation environments. So let me see. Belinda, what is a metric?
A matrix?
Mhm.
Like a system?
System of equation.
Sorry, what'd you say?
What is a metric?
I'm not too sure, but I've heard of it before.
Yeah, it's okay. I just check how much you know. How about Stephen? What is a metric?
Isn't it like the way you store like the numbers for calculation?
Yeah, for two-dimensional data, you store it for the calculation. But what calculation you will do for metric?
Is it like adding, multiplying and stuff?
And why you need to do adding and multiplying? All the math you have adding and multiplying, but why are you doing the metric for adding and multiplying? What's the purpose for doing metric?
I don't really know.
Okay, it's okay. I just check if you know. How about Tiger? Do you know?
Don't they like people use it for like system of linear equations
Yeah, but why do you need to use a system of equations?
to find like
Find equation?
multiple unknown variables?
Not only that.
Uh,
Not only that. Metric is more than that, okay? So let's see what's the purpose of the metric. So to know about metric, first thing you need to know is you need to know about metric for transformation. Okay, so metric for transformation, let's look at this. What is metric for transformation? Right here, this is Wikipedia, okay, and right here it has some transformation and doing matrix operations, okay? So doing a lot of matrix operation, but however, this chart is more important. Let's look at it, okay? So this one tell you like when you may have a square like this, and you want to make it bigger. You want to make the square bigger, so you actually multiply by a scaling matrix. So this one is for scaling. Will make the object bigger. So this one is called translate. Translate means that you have from this point move to this point, from this point move to this point, from this point move to this point. So this translate is movement. Move from one point to another point. Okay? And then you may have rotation. Rotation means that your point from this point rotate to here, rotating with a theta right here. This point moving from here to here, that's rotation. So this one is a rotation metric. And then you may also have the smear, shear. Okay, shear is a tilting. Your object may be tilted. Originally is a square, but it tilt this way or tilt this way. X tilt or Y tilt. So these are different kind of transformation that will change your object. Scaling, translate, rotation, and shears. These are different transformation that you will calculate. Okay? And then these are different metrics that you will use. Okay, so this one is the so-called metric. How you use metric to calculate your movement or your rotation or your scaling, your object become bigger or smaller, right? So Harrison, let me ask you a question. Why do you need to calculate the movement of an object or making it bigger or smaller or rotating? In what situation you need it?
Like when creating like a website and have like moving objects or like
Which
calculate
kind of the website you would need this the most?
HTML.
No. Most of the time you don't play HTML for this. Your HTML, you mostly maybe just doing the website design. But most of the people will use this kind of metric in the game design. Is that okay?
Yeah.
In a way, you are correct. The website need to have this different transformation. That's correct. Okay. We do teach you in the HTML part, we do teach you this. But this different metric is highly used in game. When you design game, you have a baseball. It moves from one point to the other. It is a movement, it's a translation. And then there's a projection of the ball you need to draw on the diagram or on a scene. You need to calculate. Then you need to use a metric. Okay? How about Jiang? Is there other application for metric?
I saw something that it's not for like transform, but I saw it on a lot of AIs when they're calculating the
Which kind of AI would need this transformation?
machine learning.
What kind of machine learning would need it?
I don't know the exact name, but the ones that needs weights and bias.
Yeah, you kind of true, but you did not point out which type of thing that you need. So basically, you have, let's call it edge detection metric. There's a edge detection metric. There's a transform kernel doing edge detection. So edge detection is used in AI, so it will detect an edge. So when you give them an image, they'll detect the edge. Okay, they try to detect this edge. So if, for example, you have a person you want to identify this person is who, okay? Or you want to figure out a fingerprint. Then you need to detect the edge. So edge detection is one of the major filter or metric you need to use. Okay, so because you want to do edge detection, so you need to use some metric for calculation. And this one is a Sobol edge detection metric. Is that okay?
Yeah.
So what I want to say is that, yeah, AI needed and AI use it for pattern recognition, and AI has edge detection, connected component detection. This is edge detection, okay? So you want to identify this one is a flower of the lotus, then you actually try to find its edge. It's okay? So you do the metric operation because you may want to do the edge detection. You may have, there are tons of image processing filters. Okay, there are tons of image processing filter. Let's call it image processor filter matrix. So these are transform kernels. Each of the transform kernels is a matrix. So here identity, reach will detect this. Okay, it shows the effect right here. So all kind of detection. Some give you the blur, some give you the Gaussian blur. So your image go there, operate on the matrix, then the data will be transformed based on the purpose of your filter. Okay, so what I want to say is that graphic or image processing would be highly depending on this kind of the metric calculation. So ball game, metric operation, image processing, AI, game design, everything needed. Everything needed. Okay. And maze, solving the maze also needed. So these are the motivation for doing the 2-dimension or more dimension data. Okay, now, so we know what's the purpose of doing this. We will later show you some example, okay? We'll later show you some example. Now, next one, let's look at one 2-dimensional table. This one is the distance table. So distance table from Chicago to Chicago, Boston to New York, New York to Atlanta, whatever, okay? So you have city to city distance. But this one, as I mentioned before, this one actually is K-graph. K-graph means the 7 city, they will have C7 pick 2 relationship. So their Boston to Chicago is the same as Chicago to Boston. These two distances are the same. And New York to Chicago and Chicago to New York of the same distance. So basically, your upper triangle is symmetric to your lower triangle. But this kind of the mutual relationship can be represented by a multi-dimensional array, 2-dimensional array, from CT1 to CT2. Is that okay?
Yeah.
Okay, so this one is 2-dimensional matrix, one of the example. Okay, so we need to declare 2-dimensional array and then processing it. Okay, we'll show you how to do it later. So 2-dimensional array, you actually would do matrix equals new integer 5, so you create a matrix of 5 by 5, 5 by 5, 0 to 4, 0 to 4. This is the number of the rows. This one is the number of the columns. So the 5 by 5, okay, 5 by 5 matrix. And then each individual data can be accessed by 2 index, 1 row index, 1 column index. So this one is the matrix 2, 1 equals 7. You assign 7 to it. And your metric can be represented in this way. Okay, let's actually look at example. Okay, you can create the integer bracket m equals new. Let's do this up to here, okay? And then you can print it. First thing is that if you write integer bracket m, or you write integer n bracket, either way work, but we prefer the top way. Okay, this one is Java format. Okay, this one is C double plus format. Style of the writing. So we do not prefer to write in this way. Okay, if you get used to C double plus, that's okay. But in Java, we prefer to write in this way. So you know this is written in Java. Okay, so that's number one. First thing we like to talk about. Second, you create this one. You declare a two-dimensional array. Again, this one is only a reference. So it's holding the ages of the two-dimensional array, but the data nowhere. At this moment, the n still be null. Okay, but right here, it actually, because you are using the local variable, so this one is not allowed. It do have a warning. So right here, you have to assign it as null. So that's actually is a reference pointing to nowhere. Okay, let's get started from here. It's also a reference data type. So you print it, it actually got null. At this moment, this address is holding nothing. You do not point to anywhere. Now you can do m equals new integer 3. This one, okay, so the first one, this one we call it declaration. You declare m is a reference variable pointing to two-dimensional array, and this one we call it instantiation. So create the object. So now, because of the new, you create a 3 by 3. 3 by 3 is like this. You create a 3 by 3 matrix. And this whole thing in heap. And the address of the 00 being stored in M. So M is pointing to here. This is called instantiation. But so after the instantiation, everything will be 0. Any questions so far?
No.
No. No, if we print it, what will happen? So Harrison, when we print it, what will happen?
Will it print like array like a array like if you having like a two string thing like with the percentage and like the index after it?
No. you kind of try it, but it will give you this. So this one tell you it's an integer array, two-dimensional array, bracket, two-dimensional array. At this edges, this is a H code edges. So that's H. The data type is integer two-dimensional array. H is right there. You print out this. But this one actually you pretty much don't know how to use it. Okay, you actually don't understand what they are. But you will print out this one. Now, how can I print out each line? How can I print out each line? So basically right here, you do have a M. M is pointing to a two-dimensional array. Okay, these are conceptual. But in reality, first thing you need to know about two-dimensional array, you need to understand that two-dimensional array is array of arrays. Okay, first thing you need to understand is two-dimensional arrays, array of arrays. What does this really mean? This means that you have two-dimensional array, your M actually pointing to an array. So this array has three tuple. Each tuple has three data. So when you print out the M will give you the two-dimensional array with edges. Now, if you print out this one, each one of these, then what you will get is three pointers. Okay, let's print out this one. M2 string. So you print out this. What does this mean? This means that M is an array of three array. So M pointing to an array object, and each one of these is an array as well. So when you do array status string, you print out each variable here, reference variable here. You will not get the contents of the array. It's okay? Hello?
Yeah.
So if you want to print out the array, you cannot do this. You cannot print the metric by itself. You cannot do array to string. Both will not print out the content of the string, content of the array. So you will need to have a function to do it. So each array you print out by this, that actually is okay. Okay, so now we print out 3 arrays. So each one we print the content of the array by array.toString of each row array. So now you have a M. M is a 2-dimensional array. So basically it's pointing to array. This array have M0, M1, and M2. And then M1 by itself is another pointing to another array. M1 pointing to another array. M2 pointing to another array. Okay, so you do array.toString on each of this one, you should be able to print out the content. So this one we call it a row array. Is that okay?
Yeah.
So a matrix is a 2-dimensional array of 3 row array or multiple row array. Each row array by itself is an array. Okay, by itself is an array. Okay, this is the most important part you need to understand. Make sure you remember it, okay? Let me take a picture on this. You need to draw this one, making sure you understand that array is a row is array of arrays, as each row by itself is by itself is an array. So when you say m the length, and the length doesn't mean that you are asking for how many elements in the matrix. No, it actually tell you how many rows in the M 2-dimensional array, how many rows you have. So when you do M1, the length, this is the length of the row matrix, row array 1. That is the length of the row array 1. So you do M1 the length. So M the length is number of the row array. M1 the length is number of elements in the row array M1. Is that okay so far?
Yeah.
Yeah.
Okay, so this is the most important part in Java array, okay? Java array in a way is different from C++ array, C language array. That's totally different, okay? The concept is really a lot of different. So later when we go to the C++, you will see the difference. The concept is different, but right here you have to learn Java array first. Okay? Now, this one is to do print matrix by each row array being printed out. You can also actually try another one. Let's call it display array. It's still printing the array, but I use a different name. So right here, you actually, for each row, you go to print each column. So each column need to less than the length of that row vector, row array. And on each row, you will change line. And then in the middle, you print out each of the data. So each data, you use a MIJ to get access to the data. This is wrong. This should be I. Okay, I'm sorry. Okay, so you print out the whole matrix. Okay, so this one is a traversal. First traversal, you actually print out every data in the matrix. Now next one you may want to update some data. So next one we will update some data. So that's it. As soon as you actually update M11 with 100. And you display the matrix one more time. Okay, so only one, the location row 1, column 1 being updated with 100. Okay. Is that okay so far?
Yeah.
Yeah.
Okay, now I think this one metric. Okay, let's actually try to get something. Okay, now let's assume that we want to write a board game for tic-tac-toe. Belinda, what is tic-tac-toe?
Like a game,
Mm-hmm.
and it uses a 3x3,
3x3, and then
and there's X's and O's.
mm-hmm. So 3 in the line, you win, right?
Yeah.
So let's assume that we want to write a game board that is a tic-tac-toe game. So let's design a board. So right here, I will have character array, cell. Let's call it M. M is easier. Okay, and then I have a constructor called board. An integer n. Okay, and then n will create a n by n game board. So this one later we can use it for larger game board, but right now that's just used for tic-tac-toe game. So you actually get these, and then you n. Okay, you have m. So m will be equal to new char n by n. Okay, and then you say for let's actually do this. This one you do that, and then later you may have a function called public void reset. And this reset you will do for integer I equals 0, I less than m balance, I increase for each row. Then for each column, integer j equals 0, j less than m, I balance, j increase. And then right here you do system.out.f percentage 2s, and then with your char. It's a vector, so I will convert it to string. So it's m ij being converted to string. And then when you finish one line, you will do system that. Oh, no. I'm sorry. I tried to print it. No, that's wrong. This is wrong. I actually would do n ij equals s. So as I haven't defined it, let's actually define it. So I'll define final static char x equals x final static char O equals O. So this one are constants. So constants, when you have X means it's actually putting a X mark in there. You put an O mark, it put a O in there. So you have a S mark. I want to use space, but space you cannot see, so let's use an underline for it. So this one is being initialized to with all of the S in there. Now, this is reset. So you create the game board and you also reset the game board. Is that okay? Hello?
Yeah.
Yeah.
So in a way, I'm teaching you the object-oriented programming right now. I'm not using the static program right now. You see, there's no public static void main right now. Everything I'm writing is a class, instance variable. Okay. Now, so the game board. So basically, you define a game board. You define a game board. 3 by 3 game board. Right? That's you actually initialize it and you actually reset it to be space. Right? So this reset is to reset it to space. Now, you may want to have a function that's called public void show. You want to show, okay. You want to show it, so you will actually do, now let's actually look at the show that you want to have. So what you want to have, maybe you want to show like A, B, C, and then 1, 2, 3. Okay. And then you XO right here. Okay, so that's the game board style that we would like to show. So let's assume that this width is 2, 2, 2, 2, 2, 2. This one is also 2. Okay. So let's see. We will do. Okay, you print 2S means that you print 2 space. Okay, so print 2 space, you just give them an empty string. That's actually is fine. Now after that, you will actually do for integer I equals 0, I less than n, I increase. So you are going to print out your ABCD now, right? You would like to print out the ABCD. So system.out.print F, okay. Percentage 2C, C is a character. So every 2 character, every colon 2 character, which character your I plus A later, and then convert this I plus A later to char. And then after you finish, you system.out.print line, change line. So that's it. This is a show, okay? This is show. So this n, okay, n we need to store it. Okay. So here let's do integer dimension. Let's call it DIM. Okay. So there's a variable called DIM dimension. Okay, so that's that, and then let's try to test it. So we have a ball class, so now let's do test ball. Okay, again, I'm teaching you the object-oriented way of doing coding. I don't use the main program, okay? I don't use the main program to call another function to call another function. This is purely object-oriented. You write the object first, class first. Okay, and then you test it. Okay, you do test program. So this one, you create a ball and then display it. So ball B equals new ball of the three row, and then B dot display. I'm sorry, did I use this display or show? It's called show. Okay, create a ball and show it. And then this is just showing the ABC so far. So it's actually two space and then ABC. Okay, that's good. Now I'm going to go over each row. I'm going to go over each row now. So go back to your ball. I'm going to go over each row. So you have 3 rows. So you do for integer I equal 0, I less than dimension, and then I increase. Okay, this one actually you can use M as well. So let's use M. Use M the length. Okay, this is the number of the rows. And then for each row, you will print the number. So basically you do system.out.print line. Printf for percentage 2-digit, but you align to the left. And then your number I will be I plus 1. You're starting from 1. Okay. Then you print out your ball mark. You print out all your ball marks. So you do for integer j equals 0, j less than m I the length j increased. Then you print out system.out.print line printf percentage 2c for your mark. Mark is m I j. And then after you finish a whole line, you change line. After you finish the whole matrix, you also change line. That's actually, this one that's actually changed for 2 lines. So do /n/n. Okay, so you print out this. It's okay?
Yeah.
Okay, now you want to place some stone into there. So you would have to do get ij and set ij. Now let's do public char get integer row, integer column. Okay, and you may have another function public void set integer row, integer column, and the char mark. So your M RC would be equal to the mark. Good enough. Go back to testboard. So you do show it, and then you do for that set 1 with X for the set 2 with O. Okay, let's change it. Let's don't use this one. Let's actually use for that X. That's a constant that we have for that O. Copy more. And then let's show the board again. Go. So this is empty board. This one with data. So whenever you put one stone there, you will update the board locations. And then you keep doing that, and then you also need to set up the rule checking. Then you should be able to write a tic-tac-toe game. Okay, and today we are not going to finish it. I'm just giving you the idea of how to do object-oriented programming over the two-dimensional array, and that is the board. So board is a class that maintains all the data and the related information in here. As for the testing, don't put the testing code here. Testing code just put into the test board. Don't put into your board. Your board just have the related constant, related data, related dimension, related constructor, getter, setter, resetter, show. These are, you have a game board. You have a game board. Whatever you want to do, put data into there, get data out, printing it, everything related to the game board, related function put into this class. That's called object-oriented programming. Is that okay so far? Hello?
Yeah.
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 That's the purpose of doing this, okay? And here we show you a simple two-dimensional array and how to use it, okay? How to use it. So that is a game board that we actually show you, okay? That's a game board we show you. So this one is a game board, two-dimensional game board. So we do talk about how to create a matrix, how to print a matrix, how to update some matrix. Okay, let's continue for matrix number 2. So there are situations that you may want to create a matrix of 1, 2, 3, 4, 5, 6, 7, 8, 9. That's assume that you want to create such a matrix. Okay. And you need to create a matrix by example. So you do integer m equals. So you do curly brace that tell people a matrix. Inside here, you should have 3 row vectors. So 3 row vectors is 1, 2, 3. That's 1 row, comma. Second row, 4, 5, 6, comma. Third row, 7, 8, 9. Curly brace. There's no comma on the third one. So this one create a two-dimensional matrix. By example. Is that okay so far?
Yeah.
Now we finish that. Next one is that we want to print it. So printing function, we will not redo it. Let's copy this one from the matrix one, we will use the same one. But it's a pre-matrix, I'm going to delete it, okay? We don't need that because that's just for example. So let me use this pre-matrix right here. Non-static, okay, here must be static. Okay, so print on a metric. It's a little bit too far, so I'm not going to use 5D. Let's change it to 2D, okay? Because we use the smaller numbers. How about let's use a 3D? 3 allow 2-digit. Okay, so that's that. Now, so this part is the print matrix. We have the matrix we printed, okay? So next one, you may have static integer array R equals okay. So the first row we have 4 data, second row we have 2 data, third row we have 3 data. First of all, is this okay? This stage is okay.
Yeah,
Why? Why is okay or why is not okay?
because you can just initialize it with the curly brackets. Oh, actually,
You did not answer my question. My question is why is okay or why is not okay? In a way, if this one is a C language, you have to do A34. So C language, you actually already fix the size. So this will not be allowed in C.
yeah, because in Java, if you use curly brackets, you don't need to like define the size. So you can just the rows can have different sizes.
Yeah. So that's what I say. It's actually called array of arrays. So basically, your R pointing to an R array of 3 row vector. First one, 4 data. Second one, 2 data. Third one, 3 data. This is called array of arrays. In Java, this is okay. In C, no. C doesn't allow this. Okay? Hello?
Yeah.
Yeah.
So that's the array of arrays. You need to understand what is array of arrays. This is key Java's difference. Okay, we do have that, and then we are not trying to show try this forever. Okay. Now next one we are going to go for the Let's go for the algorithms. So this is called record array, okay? This type of array, we call it record array. So record array, if you do metric length of 5, it should be 5 because 0, 1, 2, 3, 4. Metric 0, the length is the number of elements in the first row vector. That would be 5. Actually, metric 1 of the length, it is the row vector length of this one. That should be 4. So basically, this different one have different lengths. You have to know which one you are talking about. Because Java allow this kind of array, we call it record array, okay? Record means this, in and out, okay? Record means not regular, means a poor people's clothes. When they say record, it's something that is broken. Okay? Hello?
Yeah.
That's what it means, okay? That's what it means. It's called record array. It's broken array. Okay, but you need to know about this. And then we are going to go into the array, two-dimensional array processing. So we'll go through this different algorithm now, one by one. So you actually will see how this can be done. First one, we would actually initialize array with input values. So let's use a random value for it, okay? Okay, let's assume that start and end are the number that start from start, end at the end. The end is included, okay? End included. Okay, so you will actually try to do a matrix of n by n, so you do integer matrix. Let's don't use m, let's call it t. Okay, create a matrix and then return it. Now you want to initialize each data in the matrix. So you try to update each of the cell, and this cell will be matched at random times the range starting from start, ending at the end. So end minus start plus 1. Let's see, let's assume you are from 3 to 5. So this one totally 3 possible numbers. So it's 5 minus 3 plus 1. So it's like this, okay? So you time this one, and then the whole thing need to be quantized. After you quantize it, you press the start. So this number will be from start to end, including. It's okay so far?
Yeah.
The formula we told you, you must remember it, okay? Don't wait until you actually go to the exam and then try to get it out how to write a random call, okay, you are in big trouble if you keep doing that. This type of the formula, you have to memorize it all the times. So here, let's do integer matrix. G equals get matrix of 3, 3 from 1 to 9. Let's do 1 to 100. And then let's do Fourier matrix G. Okay, this one we finished. Let's close it. We don't need it anymore. Okay. Question: how to generate the data that don't repeat? Here you apparently some of the data repeat. And then how can you create a random data from 1 to 100, but no duplicate? Put it into this matrix. This one is the question. Who can answer this question?
Wait, within 1 to 100 or within 1 to 100 or
One within 1 to 100, but you cannot repeat it. So here we have 41 that repeat. But if I still want to do 1 to 100, but I don't want to have the 41 repeat, how can I do to avoid it?
make an array list?
Hmm?
Make an array list of already added integers
Array of integers and then
and check if it's duplicated.
you check the array whether the data duplicate is order of n is quite a lot.
Wait, can you do like a value of and see if it's -1 and then decide if whether to add or to generate a new one?
You say again?
Use value of to check if it returns -1, which means that there's no that number in it already.
Not actually, it's order of n. You have to check the whole array.
And how about use a set and store all the numbers, and if the set's length is less than 9 when it finishes, then generate a random value again.
Yes. So if you want to do it smartly, you use a set. So let's assume that 41 is in the set. Then you check the set is order of 1. Then that's fine. Don't use the array list. You know what I'm saying?
Yeah.
So one way to do it is that whichever number you created, put it into the set. So when you try to create another one, check if the number in the set or not. If yes, you have to redo it again. You have to redo it again, okay? Is that okay? If not, then you
Yeah.
use that number and put that number into the set. If yes, you have to redo it again. So using sets, okay, it's the order of 1. But if you only have array list to do, if that's limited that you do not have a set that you can use, you only have array list you can do. Then what you can do right now is actually use a for loop, creating an array list data of 1 to 100. Then you randomly pick one number, say let's assume that you pick 41. And then put it into your matrix and then delete it. Next time your array list is shorter, you can pick another one and put it there and delete it. Pick another one and delete it. So in that way, you can use array list and still is order of n only, because you create n data, it's only order of n. You do not need to check the whole list every time. Does that make sense? Okay, these are programming skills. Just give you the idea of how you can do it. Okay, just go over it. There are several ways you can do it. Okay, there are several ways you can do it. We are just talking about the possibilities. Which one can be smarter? And the discussion like this is related to the algorithm. Okay, later we will go into the algorithm part. Second, printing array, we go in already. Now summing all of the elements. So let's do sum. Printing is this a print matrix, so it's okay. Now this one is sum. These are not that hard, so we just quickly finish the algorithm, okay? Okay. This is calculating of the sum. Okay, whatever it is, okay? Next one is summing all of the element by column. So let's assume that you have 1, 2, 3, 4, 5, 6, 7, 8, 9. We want to have the sum of these, and these. So this one is 12, this one's 15, this one is 18. So we want to have this sum, okay? Vertical sum. So vertical sum, because you have 3 columns, so you should have a row vector of sums. It's not only one element, it's a 3 column. So you need to know how many columns are there. So you use a M0 that ends. Then you go over every cell. So for each column, you set a sum equal 0. So this one is for each column. So let's use a C. Okay, so C less than N, 0 events. And then inner one, let's use R for the row. But row column still row before column. Okay. And then you got your S finish your S, then your CC's column should be equal to S. Okay, you got an array. You want to print out all the data, so you actually convert that array to a string. So here you must use a string format to print it. So this one you need to import it. So let's see. This whole thing 110, yeah. This one 77, 87, 93. Okay. So this is correct. It's okay.
Yeah.
Okay, that's the column sum. So sometimes they will calculate the column sum, sometimes they will calculate the row sum, but okay. So next one is the which row has the largest sum. Okay, so this one we still continue with this get column sum. It will say which row has the largest sum. Okay, so let's rewrite it. Okay, I don't want to copy it. Okay, get largest row index. Okay, so you actually see if the sum is bigger than the maximum row so far. If yes, you update the maximum row sum and the index, okay? And at the end, you return the maximum row index. Okay. Okay, this row is large is 2. Oh, I'm sorry, this one. 80, 85, 78. Okay. It's starting from 0, so this row 1 is this one. Any question?
No.
So that's the row sum. Let's continue. So next one we will do finding the smallest of the index of the largest element. So this one we do have okay. So large element is this one. But this one you have a row and column. How can I return the row and column? Two numbers. You find the maximum number is actually 9 right here. But how can you return the row and column? If I have a Jiang, how can you return two numbers by the function?
Wait, can you say it again?
You look into the matrix, there are 9 elements. You look for the largest element, that's 9. So can you
Yeah.
return the row and column number for it? I want to have the index including the row index and column index.
Yeah, you can return the row and column index.
By what?
Hmm?
You can return row and column by what? In
I mean,
which way? In which
Oh.
way?
I usually use like a entry, or you can use like a double. I mean, int, a vector.
In Java, what should you do?
Uh,
Whatever you say, maybe Python, maybe C double plus, but that's not
I
Java.
forgot what it's called, but int bracket.
What do you mean by bracket?
Like the basic array.
Just array, yeah, there's a 2-element array should be okay. Other than that, any other way to return it?
Entry.
No. I will ask another person. Kirsten, do you know how to return the two numbers?
Sorry, do I know how to what?
How to return the two numbers, the row index and column index for the largest element?
You find the largest element first and you keep track of the row and column.
Yeah, and then how do you report it? How do you return from the function?
You can return with a array.
Yeah, we talked about it already. Any other way?
The tuple.
Java don't have tuple.
Oh. I don't know.
Anyone know?
I'm not sure.
Harrison, do you know?
I'm not sure.
It's very easy, okay? Let's look at it. Finding the maximum is not hard. Okay. But reporting it, you need to know about this. This one, I think in AP, they may test you. Remember the insert location, we call it I numbers, right? So here, let's do it this way. Let's do it. Let's call it G number. So when you do binary search, you want to find the insertion location. We do I number. I equals -1 minus low. So use that to carry the information of your insertion location out. And then in the outside, you want to calculate the I, your low should be equal to -1 minus I. You will recover it. Okay, that's the technique that we will use. So right here, you want to get the maximum number, the greatest number. So we call it G number. So G number is an index number for that, that maximum number's location. Okay, so one way you can return it is you do integer. Java don't have tuples, so let's use a vector. So let's do V. And then you return it. Okay, this is one way you can do it, but this one actually, let's copy something over. This one is simple, but right here, you do need to have an integer max equal 0, integer that mean that let's delete this. Let's delete this. Okay, so this is a simple way to get it out using an array. Okay, so you use a VI0, VI1 to remember your G that's actually defined. In Java, there's no tuple, there's no other data type that you can use. You can use array list, but that's actually a lot of effort. So this one, you have this row 1, column 2. This one is the largest number. Okay, now you have duplicate, but it's okay. Now we have another way to do it. So this is got G number that's copied for number 2 version. Number 2 version, we don't do this. We do integer maxima row equal 0, integer maxima column equal 0. Okay. So we don't return it that way. We do return maxima row times we return this number. Row times number of column plus your column number. So let's see, let's assume that you do have these. You have row 0, 1, 2. This is column 0, 1, 2. This number, so row 0, column 0, you get 0. Row 0, column 1, you get 1. There's a 0, 1, 2. This one will be 3, 4, 5, 6, 7, 8. This is G number will be equal this. Okay, once you get it, you get out, then you will calculate its row and column based on these G numbers. So let me copy this one for you. This is very important, okay? This one actually very commonly used. When you don't have couple, you still want to report two numbers, there is a way you stack up the numbers. There's one way you can stack up the numbers. Okay, so right here, let's actually repeat this portion. Okay, so this one, let's call it G number, G number. Is get G number 2, okay? So you get G number 2 and then you get a G num. You get G num and you want to recover the data. So let's see, your integer row should be equals to G number divided by G the length. I'm sorry, G0 the length. Your integer column should be equal to G num take modular by G0 the nums. This. And then you should get your row and column. So one number you can carry out your row and column. Okay? Any question? Again, this one is using mathematical calculation. Where is my... This one is using mathematical calculation. Let me tell you one more time. Your original matrix is 0, 1, 2. Zero, 1, 2. You want to put your G number as this. This 1, 2, 3, 4, 5, 6, 7, 8. This is your G number. So G number divided by number of column, you get your row. G number take modular by your number of column. Number of column is 3. You get your column number. Is that okay? Very, very important in two-dimensional data to serialize to one dimension. Okay. Let's assume that we have a rational number a over b, a over b. So right here you may have let's assume this point is 1 over 1. So this point is 2 over 1. This point is 1 over 2. So something like that, okay? So you have a number with the two tuple 1, 2, 1, 2, 1, 2, 2, 1, or whatever for all of the rational numbers. And you have another set. So this one, let's assume this one is called rational numbers. Red, let's call it red set. There's another number set that's usually it is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And continue. All of the natural numbers. Okay. Now my question is, this is set bigger or natural set number bigger? For Kingston, which set is bigger?
Neither.
Neither means which one is bigger.
I don't know that none of them are bigger.
None of them. So you have A set and B set. It must be A bigger than B or B bigger than A. Or A equals to the size of a B. Which one of these? You can only have these three possibilities.
A equal B,
Why?
because they go on forever.
They go on forever, yeah. But how can you prove that they are equal?
For every rational number, you can create a natural number. You can create a natural number from every rational number. I mean, you can map a rational number to a natural number.
How can you map it?
I don't know. There's some like, there has to be some kind of mathematical equation or something.
Okay, I heard you. How about Jiang? Do you know?
You like explain the question more specifically. Like I can't kind of
The natural number set and rational number set, which one is bigger?
what?
The set of the natural number and the set of the rational number, which set is bigger?
I don't know.
You don't know. How about Harrison? Do you know?
I think it's rational numbers.
Okay, that's what you say. How about Stephen? Do you know?
I think they're equal
Why?
because both can go on for like infinitely.
Yeah, go
Infinitely
on infinity. That means they are equal.
Oh,
How about Belinda?
I also think they're equal, but I'm not too sure.
Okay, the answer is they are equal. They are equal, yeah, they are equal, they are infinity, yeah, they are the same, but you actually can do serialize 1, 2, 3 using zigzagging. So each of the ID 1 to n will map to a rational number in this two-dimensional matrix. So there's a one-to-one mapping from n set to rational number set. If you do zigzagging, you can serialize it. So that's what I'm saying right here. Same thing right here. The two-dimensional matrix, you may have the G number that actually have two index, but there is a way you can do serialization. The serialization that help you to do the two-dimension to one-dimensional conversion is this. And in a finite set, this is absolutely true. Is even more true than the kind of infinite set that we talk about for the rational number and natural numbers. Okay. So if you want to do computer science, your math must be very good. How good you should be, not just the top of the school. That's not enough. A better person that maybe is USACO champion, or USAMO champion, or IMO champion, gold medal. Okay. Sky is the limit. You try to shoot for as high as possible. Math is the no limit. You try to get it, okay? Anyway, that's study of the math to help in CS. That's why we do random shuffling. This shuffle is very easy. You just pick two number and do a swap. That should be okay. Let's do finish it and finish up today, okay?
Okay.
There are several ways to do shuffle, but we just demonstrate one shuffle way. Later, if we have time, we will show you multiple way of doing shuffling. So this one, let me copy any of the row and column. In a way, you need to keep practicing your programming, but math, you also need to improve. Otherwise, when you go to advanced programming, you cannot handle it, okay? So for each ij, you will actually try to swap it with another number. So let's actually create integer row equals mass random times n length. So each of the row number so you get a row number by this, and you want to get another column number. So you get a row and column. Your original data is at the ij location, index of ij. Now we actually get a different one that actually at the row column. Now you want to swap these two elements. So integer temp equals n ij. Just swap. And then n ij equals n row and column. Okay, so this basic swap, I won't explain it anymore. You actually need to know. If you still don't know, you are in big trouble. Okay, that's a shuffle. So let's do for integer I equals 0, I less than 20, shuffle 20 times. Shuffle your G for 20 times, and then ring metric for your G. That's it for today. How comes G so? And declare match. Okay, it got shuffled. So we finish this part up to here. Okay, more advanced algorithm will cover in next week. Okay, any questions so far?
No.
Any question on the homework or anything else? So the algorithm is getting harder and harder every time, okay? So you need to remember them. Also, the technique we teach you, for example, the insertion number, G number, you have to pick up, okay? If you don't pick up, you are in big trouble. You really need to understand it. And then later, you may be able to design your own algorithm if you need to just carry one number back. Okay, you have to use it. Later, we'll use it again. So today we demonstrate a two-dimensional array and then also using the simple tic-tac-toe game ball. We do not put the game rule yet, but later when we have time, we will put the game rule to make it runnable, to be playable game. Okay, but right now we just finish the ball painting part. Okay, and then we also working on the basic metric algorithms. Okay, and then one thing that I would like you to know is like we do teach you in the lectures about the language and some algorithm. Okay, so this one lecture we cover the language and algorithm. So we do have the solo learn. We want you to use the solo learn to basically know about the syntax for Java. Okay, that's the level 1 practicing. You need to know about the syntax for Java. If you don't know about it, you better practice it well. Don't rush yourself. Many students rush yourself. So later when you go to coding bed, you still have trouble. Second level, you go into coding bed. They are level 1, 2, 3. Each one of them getting harder and harder. So in the level 1 or 2, you need to build up your habit of calculating the index. When you have a window, how can you deal with it? When you actually do sorting, when you use a running index, how are you going to use it? Those kind of algorithm you need to remember so you can proceed from level 1 to level 2 to level 3. And then this actually complete the Java level 1 and level 2. Then you go to user code for branch level algorithms. So these are step by step. If you cannot handle the level 1, 2 in here, you are basically out of CS already. You are out. So if you are not good over there, what can you do? You go back to your fundamentals, redo the coding back, making sure each problem you can solve by yourself. And you cannot say, oh, let me wait until I have the problem. Let me think about it. This I need to do this, and this. That would be too late. The calculation of the midpoint or the calculation of the index need to be in seconds. You have to figure out how to do it right away. If you hesitate, then you cannot go into the level 3 or the competitive programming because your basic is too weak. You cannot do it. You cannot handle the intensity of the competitive programming. Okay? I can only tell you the train and how I train you, but if you don't want to follow, that's your own problem, okay? Then you are out, definitely. Okay, thank you. Good night, bye-bye.
But I
Bye.
think
Thank you.